Welcome back. I hope that you were able to kind of rest a little bit after this long sequence. And what we did in the first part of this lecture is take the description, the informal description of the expression problem, of the expression problem, of the countdown problem. Expression problem is something completely different. You can Google that, and again, you can spend years trying to solve the expression problem, but we are trying to solve the countdown problem here. And what we did is we constructed a brute force solution where we just generated all possible expressions and then checked whether they satisfied the rules of the game. What we're going to do now is we're going to try to check if we can avoid to generate invalid expressions up front. Okay? And our hope is that this will definitely give us a performance improvement because, there's only, quite a small fraction of all the possible expressions are valid. And so the way we're going to do that is we're going to look at pairs of expressions and their values. Okay? So this is the expression and this is the value. So we carry around both the symbolic representation of the expression and the numeric representation of the expression. And what we want is we want to have a function that fuses together the generation and the evaluation of the expressions. So this is the result of evaluating the expression, and that is the result of generating the expression. But we needed the result of evaluating the expression to check whether it satisfied the constraints of the game. Okay? So that's what we're going to do. We're going to try to define a function that will combine the generation and the evaluation. And the way we can do that is as follows. If we want to find the results for the empty list, well, that's the empty list. When we want to generate the combination of expressions and their values for a single list, well, what do? We did what we did before. We generate the expression. We know its value. But this is only valid, remember, when the number was greater than 0. So now we can put this test right here. And the rest of the code is now fairly obvious, where we just do exactly the same, except that we recursively call results. Okay? And then we still have to define the combine function here that will do the same thing, that will kind of check whether the results are valid. So here is combine. It's exactly the same as our previous combine function, except that now we also check whether the results are valid. And you see that we can do that because we are now carrying around a pair of the expression and its value. And that allows us to check here whether the result is valid as we are generating these new expressions. So it's kind of a small change, but it's quite dramatic. So here's the new function that solves the countdown problem. And it's just using this new results function here. So we take all the choices, we calculate the results given these, and then we check whether the result is the one that we want. In this case, if we run this now, it's about 10 times faster. So it's now in 400ths of a second. And also, this guy here, which used to be, what was it, 43 seconds, is now down to 3.5 seconds. This is fabulous. This is really fabulous. Can we do even better? Can we do even better? And we can, because we have now eliminated generating invalid expressions, because we were generating the expressions with their results, such that we could always check whether they were okay. But there's still symmetries that we're not using, okay? Because really, if we have x times y, that's basically the same, or that is the same as y times x. So we don't have to generate both of these two results. And if we happen to multiply a number by 1, we might as well just use x. Okay? So if we use these properties, we will eliminate, we won't be using the expressions here on the left, because they are considered to be the same as the expressions on the right. So hopefully we can reduce the search space for this. And that's what we will do in the next part. So take a small break, and I'll see you soon.